Hi, guys. Um, I'm pretty sure we're live now. So this is new to me, so we'll try this. I sent the problem um, in the module on Canvas. So hopefully you have it from my MCPS. It's actually not a very difficult problem. I did get this problem from College Board from their videos that they've been streaming for a while now. And they made this up. So I thought it'd be a good idea to look at it because it might have some things we hadn't seen before. But then after looking at it, I realized that it's kind of easy, but that's good, right? So hopefully that's a good sign. I think you can see the board. I do have the chart already up here on the board. And yeah, I don't know. Okay, so for this problem, you printed out the actual table. So you have the table of values, and there are 5 parts to this problem. So there's usually 3 to 4, so there's an extra part. I was hoping it had gone on more, but then the next problem was a different problem. So we'll start with this. I'm happy to do more tomorrow. And I did find one that was called a mega practice problem that we can do tomorrow. We'll talk about that later. I'll send you out some info on the next time we will do this. Okay, so it says part A, let g of x be equal to x squared over f of x. The chart gives us values of f and f prime at different values of x, and they're asking us in part A to find g prime at 3. So pretty straightforward, right? We're going to differentiate this expression. So for g prime in general, without putting the 3 in, although to save time, you may want to just plug the 3 in initially. I'm not going to do that here. We're going to have to use quotient rule to differentiate. So we're going to do low d high minus high d low. So it's going to be f of x low d high would be 2x, derivative of the top, minus high d low would be x squared times the derivative of the low, which is the denominator. So that's going to be times f prime of x here. Let me try to get a better. Here we go. Okay. And then from there, it's all over low, which would be all over f of x squared. Okay, so that's our quotient rule. It's time to plug in 3. So we're going to find the value of g prime at 3. So everywhere there's an x, we put the 3. So now we have f of 3. Now it would be smart just to grab it. So f of 3 is 4 from the table, and then 2 times 3 would be 6. And then here we have 3 squared, which is 9, being multiplied by the derivative at 3. So f prime at 3 from the table is negative 2. And then we have it all over f of 3 squared. And f of 3, again, is 4. So that's going to give us 4 squared, or 16 in the denominator. So then from here, it's kind of simple math. We have 24 plus 18 over 16 is what I have here. Hopefully you can see that. And then just kind of putting that all together, 42 sixteenths, and that would reduce down again in half. So we're going to go with 21 over 8 for our final answer here for g prime at 3. Now, there's a couple things about uploading files. You're able to take a photo of this problem and upload it. You upload at the end of the problem. They allow 5 minutes at the end. There are several demos. At the end of this session, I will give you the website to go on. It's cb for collegeboard.org/AP demo, and you can practice uploading. And you have time to do that today or tomorrow. I know you have physics tomorrow, but okay, so that's part A. Hopefully that's all good to go. Hopefully you can see my answer here, although it's in the corner. And then let's go ahead and look at part B. So part B in this problem asks us to use a left Riemann sum to approximate the integral. Actually, to approximate the integral, but to approximate the average value. So let's take a look at that. You have the paper in front of you. So part B, a left Riemann with 3 subintervals indicated by the table. So that's nice because the table, one interval, another subinterval. So that will allow us to do the left Riemann. So they want the average value. Be careful here because average value, of course, we know, is equal to the integral over the interval. So I'm going to go ahead and say, okay, they want the integral from 1 to 9 of f of x dx divided by the interval, which would be the difference b minus a, in this case 9 minus 1. Okay, so just checking, make sure they wanted f. There's no other function like the g that was in part A. So I think we're good. So now it's a Riemann, but we know that the answer is going to have a 1/8 in the front. So I'm going to go ahead and put the 1/8, and then I'm going to go right into my left Riemann sum here, where I'm going to take the left endpoints, the y values for f. So I'm going to go ahead and take 6 and multiply 6 by 2. And the reason it's times 2 is because that's the delta x between the 1 and the 3. Okay, plus left Riemann, take the next leftmost value. So we're going to take 4. I'm going to multiply it by the difference between 8 minus 3, which would be, of course, 5. And then finally, we add the 5, and we multiply it by the difference between the one above it and the one to the right. So we're going to be multiplying by 1 here because it's going to be 8 minus 9, right? Well, to go to 8 to 9, it's a difference of 1. Sorry, 9 minus 8. So on the end here, we're going to have, I just want to write my numbers right, 5 times 1. Okay, we're good. And then 1/8 of this amount. So basic math. So 12 plus 20 is 32, and 32 plus 5 is 37. So I'm getting 37 over 8. Now don't forget over 8 because it's the average value. It's not the value of the integral. It's the average height of the function on the interval from 1 to 9. Okay. Not too bad. I think we got that. Okay, so now for part C in this question, it asks us to integrate from 3 to 8 x f double prime of x dx. And that screams to me integration by parts because it's a product. The integrand has a product. So let's take a look at this one. I'm going to write down the integral they ask us to find. It's a definite integral. It's integration by parts. We have to remember ultraviolet voodoo, right? Ultraviolet voodoo. Okay, so for the integral, it's from 3 to 8. It's going to be x times f double prime of x dx. Okay, now remember, we did have a mnemonic for choosing which expression to let equal u and which one to be dd. And we really can't use this here because we don't know what f double prime looks like. However, just remember that you're going to assign u to be the function that's easier to differentiate. So in this case, I'm thinking integrating the f double prime would be easy because the integral will be f prime. So I'm going to go ahead and let that be dv, and I'm going to let u equal x. So u is equal to x, dv is equal to f double prime of x times dx, like that. Okay, and then we know what we do. We're going to differentiate here. So we go down, du is equal to dx. And then here to get v, we have to integrate. So v is going to be equal to f prime of x. We don't get any arbitrary constants or anything here. And then we remember the formula. I've always encouraged you to write the original integral on the left margin. In this case, I don't think it's going to mean anything. So I'm going to save time. So I'm going to go ahead and say ultraviolet is the formula. U times v is going to be x times f prime of x, evaluated from 3 to 8, of course, because it's a definite integral. I was mentioning that earlier. And then it's going to be ultraviolet voodoo. So it's going to be minus the integral from 3 to 8 of voodoo. So v du. So it's going to be f prime times dx. Okay, so this looks doable. So now I'm going to use the fundamental theorem here in a weird kind of way. So it's going to be 8f prime at 8 minus 3f prime at 3 minus hard brackets. So I remember to distribute the negative. The antiderivative of f prime, or, we can say whose derivative is f prime. Well, that's f's derivative. So it's going to be f at 8 minus f at 3. And now we need to just grab a bunch of values from the table to get the numeric answer. So now I have 8 times f prime at 8. F prime at 8 is 3, so that's going to be 8 times 3, 24. F prime at 3 is negative 2 times negative 3, so that's a plus 6. Here, I'm going to distribute in the negative, and I'm going to have minus f of 8. F of 8 from the table is 5, so we're going to say minus 5, but then the 2 negatives on the end, that's a key. I think some people might mess that up, but hopefully not. F of 3 from the table is equal to 4. So now if I just do the basic math here, I have 30 minus 5, 25 plus 4, 29 for my value for the integral. Okay. That look good. Integration back parts. Okay, so we have part D next. I'm going to write that on the board here. So for part D, they're asking us, they're introducing a new function, capital H of X, like they're known to do. Let me write H of X down here for us. So part D, capital H of X is defined to be the integral from 1 to x squared of f of t dt. And they're asking for 2 values. They want us to compute h prime of x and h double prime of x. And they also go on to ask us to explain why h could not have a relative extremum or a point of inflection at x equals 3. Okay, so let's begin by finding h prime and h double prime as we were told to do in terms of x. So h prime is the derivative. Now I'm going to use some notation here. It's the derivative with respect to x of the integral from 1 to x squared of f of t dt. I just wanted to write that so that we remember. This is the second fundamental theorem of calculus. Okay, so now we have h prime of x, and we know how to do this. You take the derivative of the integral. So you're going to compose, you're going to get f of x squared. Now you do not integrate f. You leave it, because these cancel each other out as operators. So you have f at x squared, and then remember the chain rule comes into play here. The derivative of x squared must be multiplied, because that's the chain rule. Okay, so we have that the derivative of h, capital H, is equal to, in terms of x, f of x squared times 2x. Now they want us to also find h double prime of x. So h double prime of x is the derivative of h prime. So it's the derivative of this, and it's a product. So we do need to employ the product rule here. So the product rule is going to be first function, f of x squared, times the derivative of the second function, which is 2, plus the second function, which is 2x, times the derivative of the first, which employs another chain rule. So the derivative of f of x squared is f prime, can't touch this, times 2x. Okay, so we have this big thing as h double prime. Now, they ask us about the extremum, and they ask us about the inflection point at 3. So in order for there to be an extreme value, it has to happen at a critical number. A critical number is a number where the derivative is either 0 or undefined. So if we plug 3 into the derivative of h, we can check to see if it's a critical number, and we can go from there to say if it can or cannot be an extremum. So I think I might move over to here to use this part of the board for that. So h prime at 3 is actually going to be equal to f of 9, because it's 3 squared here, times 6. Okay, so unless f of 9 is 0, 3 is not going to be a critical number. So let's check. So f of 9 from the table is equal to 2, and 2 times 6 is 12. So if the derivative is not equal to 0 or undefined, it's not a critical number. Unless it's the end point of an interval, it could be an absolute extrema, but in this case, it's not. So we can say that, it said explain why. So we can say, therefore, x equals 3, there does not exist, maybe, something like that. A relative, they just said extremum, I think, so. And I don't think you have to say since it doesn't equal 0. You've already said that, or undefined. So it's not a critical number. It can't be an extreme value unless it's a critical number. Okay, and then it asks us also to talk about whether there would be a point of inflection at the same x value, x equals 3. So let's go ahead and look at h double prime at 3. H double prime at 3 is going to be f of 9 again, because it's f of x squared, I'm looking over here, times 2, plus 2 times 3 again is 6, multiplied by another 6. So really I'm going to make that 36, because we have 2x and 2x on that add end of the h double prime. And then f prime at x squared would be f prime at 9, because 3 squared, right? Okay. I think that looks good. Okay, so let's see what happens here. So f of 9 we talked about already. F of 9 is 2. 2 times 2 is 4. And then here f prime at 9 is negative 1. So it's plus 36 times negative 1. So it's 4 minus 36. So we're going to get negative 32. So now, because h double prime at 3 is a negative number, it's not 0 or undefined. Again, it parallels with the extrema. If the second derivative is 0 or undefined at an x value, it's a possible point of inflection, but then you have to test it. So here we can't even get it to the testing stages because it doesn't equal 0 or undefined. So h double prime does not equal 0 or undefined at 3, and therefore it cannot be a point of inflection. So it does not equal 0 or undefined again. Therefore, there does not exist a POI. It's fine on the exam to say POI. They know what you mean. At x equals 3. There's a glare on the board from my light, but yeah. Okay, can't get rid of that right now. Okay, so that's that part. I think we covered everything in part D. Let's go on to part E. So part E is sigma notation, and that's good because that's a BC only topic. I think all of this would have been able to be done by AB, but this part, no. Yeah, they call this a BC problem. So, okay, so they ask us, let f of A, this is part E, let f of A be equal to sigma from n equals 0 to infinity of A times R to the n. So we should recognize right away that this is a geometric series because of the look it has, the aesthetics. That's the nth term of a geo series. And it says where A and R are constants and A is between the closed interval, a number between 5 and 8, including 5 and 8 here. Find the value of R when A is 8. Okay, so A is equal to 8. And we want to find R. Okay, so the first thing I think to do here is if A is 8, I'm going to sub it in. So I have sigma from n equals 0 to infinity of 8R to the nth power. Okay, so I know, actually, looking at the information, I know that f at 8 is 5. And so f at 8 is what this is equal to. So I can set this equal to f of 8. And f of 8 from the table is actually equal to 5. So now here's what I know. I know that this geometric series converges and has a sum equal to 5. I have a formula for the sum of an infinite geo series. That's S sub n is equal to the first term A over 1 minus R. So in this case, let's substitute in. We know that 5 is on one side of the equation, so I'll put the 5 for the sum. And then on this side, we need the first term A, but we know that A is 8. We've been told so. And then on the bottom, the unknown value is the common ratio R, and that's what we're solving for here. So that's an easy algebraic equation to solve. Cross multiply, I'm going to go over here. You're going to get 5 minus 5R is equal to 8. From here, you're going to subtract 5 from each side. Let me move this over. Basic math here. and negative 5r is equal to 3. And finally, r is negative 3/5. Just to be sure, I mean, it's an alternating geo, and that's okay. They still can converge and have a sum. And it is a value whose absolute value is less than 1, so it does converge. I mean, I'm just thinking it through when I'm finished with the question, because I was a little bit surprised it was a negative ratio, but it's not really a problem. So we were asked to find r, and we found r. Okay, so that was part E. That was the last part of this free response question. Again, I thought this was pretty easy. I don't know if this would be the 25-minute or the 15-minute question. I think I don't know, it had an extra part. I think, you have the paper, so that if anybody watches this later, you can just print the paper from the module and then I guess get the answers from here. Also, tomorrow we'll be back to do something. So stay tuned. And I'm happy you joined me. And I'll see you guys tomorrow. Have a great day. Tell your mom Happy Mother's Day. See ya.